Right. So, you know how we're always on the lookout for like the most cutting edge science, especially stuff that could help us live longer and healthier lives.
Exactly.
Well, today we're diving into some seriously groundbreaking work by this guy, Dr. Greg Fahy and his team.
Yeah, Dr. Fay's been making some real waves in the field of aging research with
Right.
his work on the thymus gland.
And we've been poring over all the details of his research, like the TRIIM trial and then this follow-up study called TRIIM-X.
Right, and what's so fascinating is that they're looking at ways to actually reverse some aspects of aging.
Like not just slow it down, but turn back the clock.
Yeah, exactly.
Now that's the kind of news we like to hear.
Absolutely.
So let's talk about this thymus gland for a sec.
Okay.
What is it and why should we even care about it?
So the thymus is this little gland that sits right behind your breastbone,
Uh-huh.
and it plays this absolutely crucial role in your immune system.
Okay.
You see, it's basically like the training ground for your T cells. Yeah, those are the white blood cells that fight off infections and diseases.
Right.
So the thymus is where they mature and learn how to do their job.
Gotcha.
But here's the catch.
Uh-oh.
As we age, the thymus starts to shrink.
Shrink.
Yeah, it's a process called involution.
Involution.
And as it gets smaller, it produces fewer T cells.
Okay, so we're making fewer of these disease-fighting cells.
Exactly, which means our immune system gets weaker as we get older.
So that's why we're more likely to get sick as we age.
Precisely.
And is this the main problem that Dr. Fahy has been trying to solve with his research?
That's right. He's been looking at ways to rejuvenate the thymus and boost immune function in older adults.
Makes sense.
And that's where the TRIIM trial comes in.
The TRIIM trial.
Yeah, it ran from 2015 to 2017 and involved 10 healthy men between the ages of 51 and 65.
Okay.
The goal was to see if they could actually regrow the thymus using a specific combination of 3 substances.
3 substances. What were they?
Okay, so the first one was recombinant human growth hormone,
Right.
or RHGH for short.
Yeah.
Then there was DHEA, which is a precursor hormone.
Uh-huh.
And finally metformin, which is a common diabetes medication.
Right.
And they gave these to the participants over the course of a year.
Wow, a whole year.
Yeah, and what they found was pretty remarkable.
I'm all ears. Tell me what happened.
Well, first of all, the participants did show signs of thymus regeneration.
No way their thymuses actually started growing back.
Yep, it seems so.
That's amazing.
But it gets even more interesting.
Oh, there's more.
They also measured the participants' biological age using something called epigenetic clocks.
Epigenetic clocks. What are those?
So basically, they're like molecular markers that can tell you how old your body really is on a cellular level.
So it's like your biological age versus your chronological age.
Exactly.
Okay, I'm following.
And guess what they found?
What?
The participants' biological age had decreased by an average of 2.5 years.
Whoa, are you serious? They actually reversed their aging.
It seems that way.
That's incredible.
It was a huge breakthrough. It was the first time anyone had shown evidence of age reversal in humans through thymus regeneration.
That's a serious aha moment.
Right?
So that was a pretty small study though, right?
True. Only 10 participants.
So what about this TRIIM-X study? Is that a bigger follow-up?
Exactly. TRIIM-X launched in November 2020, and it's looking to build on the findings of the original TRIIM trial.
Gotcha.
And they've got a much larger and more diverse group this time.
How many people?
26 participants,
Okay.
including women,
Oh, good. That's important.
and a wider age range from 40 to 80 years old.
Wow. So they're really trying to see if this approach could work for a lot of different people.
That's right.
And what's the word on the street? Are the preliminary results looking promising?
So far, so good. The early data seems to be consistent with the findings from the original TRIIM trial.
That's encouraging.
It's still early days, but it's definitely a good sign.
So if this all pans out, what are the implications for our health and how long we could live?
Well, if we can figure out how to safely and effectively rejuvenate the thymus, the potential benefits are huge.
What kind of benefits are we talking about?
Well, for starters, we could see a significant boost in immune function.
So we'd be less likely to get sick.
Exactly. And that could mean a lower incidence of age-related diseases and infections.
That's a big deal.
Plus, it could contribute to healthier aging overall.
And maybe even extend our lifespan.
It's certainly a possibility.
Now, one thing that I found particularly interesting is that T cells can actually live for a pretty long time, around 12 years.
Yeah, that's right.
So we might not even need to constantly regenerate the thymus.
That's an intriguing thought.
Maybe we could just do it periodically.
Right, exactly.
Which would be a lot more practical in the long run.
Agreed.
So, to sum it all up, Dr. Fah's work is really highlighting this idea of targeting specific organs for regeneration as a way to combat aging.
Absolutely. It's a fascinating new frontier in aging research.
And while we still need more research to like really fine-tune these methods and understand all the long-term effects,
Of course.
the progress that they've made in restoring a thymic function is really exciting.
No doubt about it.
It's like opening up a whole new pathway to improve our health span and longevity.
It really is.
This has been super insightful.
My pleasure.
It really gets you thinking, like, given how important the thymus is for our immune system,
Uh-huh.
what other age-related declines might we be able to reverse? Like maybe we could use similar targeted approaches to rejuvenate other organs.
It's a fascinating question.
And it's something to definitely ponder as this field of research continues to evolve.
I agree. There's so much potential here. It's an exciting time to be following this work.
Absolutely. All right, well, that's it for this deep dive.
Thanks for having me.
And as always, keep those brains buzzing.